Okay, second part of it's a cube roots of unity. This is like a formula you need to memorize. So that's the z cube equals 1, the unity. And as we proved before, the previous video, a complex cube root of unity, it was either cos 2 pi over 3 plus I sine 2 pi over 3, or the negative argument of that. Okay, now with these roots we can find some properties of it. So the omega square equals the conjugate of the omega equals 1 over omega, and the omega square plus omega plus 1 equals 0, and omega cube equals 1, just like the z cube equals 1. So you need to memorize all these properties. Okay, so now I'm going to do the examples. So find the 4 roots of z to the power of 4. Before it was z to the power of 3, the cube equals 1. Now it's a power of 4 equals 1, and show them on the complex plane. So you got to do 2 things here. First one, we have to find the roots, 4 roots. We have to find the 4 roots. That's the first thing. And we have to show them on the complex plane. Okay, so we got to do 2 things here. Okay, all right, let's have a look at the first one. So we're going to find the 4 roots. So let's have a look. Equals 1. I'm going to move this one to the other side, making it into 0. So it's sort of like standard general form. And that's looks like difference of 2 squares, isn't it? So I'm going to put them into difference of 2 square form right there. I'm going to push up a little. Now this is not too bad. This is the regular thing, so I'm going to do that one first. That's this one. Now this one is a bit of a problem to separate, isn't it? But luckily we know complex number. If I can change this into, say, z square minus 1, okay, so that's still okay, isn't it? And then I can change this one. I is square, because minus 1 equals I squared. Yep. So I'm going to do that. Just a little bit of that. Yep. Let's see if I could make it a little bit easy. Yep. So that's why I put that in there. So I'm going to use that. Okay. So let's see if I can change that one into. So now I've got z plus 1, z minus 1. Now I'm changing into z plus I, z minus I equals 0. I change that to this 2. Therefore, can't see that. Therefore, my roots are 1 minus 1, I, or minus I. Okay, now that's what we got. 4 roots, found 4 roots, tick. And then I need to show them on the complex plane. Okay, so I'm going to sketch this. Again, I'm doing a very rough sketch here, and you need to use ruler and pencil if you need to do it properly. Okay, 0. Now they're all going to be pretty much here. So that's 1, that's minus 1, because it's going to be just real and it's imaginary. So I minus I. Okay, so that's the roots, and I'm going to join them. that's what it will look like, or the roots on the number plane, well, complex plane. Okay, so let's have a look. So this one was alpha 4 equals 1. That was just alpha squared, alpha cube, which is same as like that. Okay, so when it's, this one was z at the start, z4 is 1, so that's what I put that in there. Okay, and that's when z equals complex number I, and then when z squared is when I squared, which is minus 1. And what's this one? I's. So let me just make it easier for you. So alpha equals I, alpha square equals I square, which is minus 1. Alpha cube equals I square times I, which is minus 1 times I equals minus I. 4 equals, which is minus 1 times minus 1 equals 1. So these are the the roots are all on the plane. Okay, so that's it.